Okay, so we're going to do another example of finding an area of a quadrilateral. This one's a little more complicated than the last one. And that all has to do with what you're given, how complicated the process becomes. So here you're given a four-sided figure where you're given side 14, the angle 110 next to the side 12, the angle 130 next to the side 8, and you're not given the last side or the angles of the other two shapes. Now, splitting this up, you might look at this and think, oh, let me make a triangle here and a triangle here, and then I'll cut this out of some rectangle and stuff and make 4 or 5 shapes. And sometimes you can do that. But the most efficient way using law of sines and cosines is to cut this shape into 2 shapes. So I'm going to cut, it could be cut from this vertex to this vertex, which would give 2 triangles. I'm going to cut it the other way for this example. It would not matter. In this particular case, it does not matter which way you cut it. So we're going to cut that. All right. We're going to call this triangle A. And then I'm going to call the other one triangle B. And we're going to find the area of both of those triangles. In order to do so, we might need to do a little work, but this is the process. Split the shape up into 2 shapes, find the area of this triangle and the area of this triangle. Now, triangle A isn't so bad because we have a side, an included angle, and another side. So that's going to be area equals 1/2 of 12 times 14 times sine of the included angle, which is 110. And that works out to be 78.93. Okay. Now, for triangle B, we have some problems here because triangle B, we don't know much about right now. We have this 130 angle, but that's not actually in triangle B. We have this side 8 that is in triangle B, and we have nothing else. So we need a side and we need an angle. So that means that this 130, we're going to have to find out what part of the 130 is an angle B and what part is an A. So we can figure that out using law of sines here. And then we're also going to have to figure out this side that we use as the cut using law of cosines in triangle A. So let's get those things first. Let's see. I'll use blue here. So we're going to call this D. Let's get the length D, the diagonal that we cut. That's going to be D squared. We're using triangle A here. So we can use law of cosines. We have side, angle, side. D squared is going to be 12 squared plus 14 squared minus 2 times 12 times 14 times cosine of 110. And we come out with D equaling 21.33. Don't round these too much. If you start rounding this, you get lots of errors. Leave at least 2 decimal places. In fact, I prefer 3. I only use 2 decimal places this time, but 3 would be better. So that's the side that's going to be in B, 21.33. Now we also have to figure out this angle. I'm going to figure out this angle right here. Let's call that angle X. So let's see, sine of X over 14 is equal to sine of 110 over side D that we just figured out, 21.33. All right, now notice we needed this. We needed the side length before we were able to get this angle. So let's see. X, using a calculator, X winds up 38 degrees. It's actually like 38.0 something. So we're just going to use 38. Again, don't round too much here, but I am just using 38 this go around. Now, if that's 38, that means that the angle here that's actually in triangle B is the balance of that, the 130 minus 38. So that becomes 92, I think. Seems like 92 degrees. And now we have this triangle B. Let's see if I can write it over here. We have this triangle B with a 92-degree angle, with a side of 8, and with another side of 21.33. And with that, we can do the area formula again. Area equals 1/2 times 8 times 21.33 times sine of 92. And that is going to equal 85.27. And then in order to find the area of the quadrilateral, we are going to add 78.93 plus 85.27. And we are going to get our answer 164. I got 798 for some reason. I guess I was keeping more decimal places in the calculator. 798 or 0.80. If you want to round to 2 decimal places, that would be fine. And so we break the 4-sided figure into 2 triangles, and we use the area formula of each of those triangles, sometimes having to use law of sines and law of cosines in order to find the missing pieces. This is like foundational stuff to use for your project. Now, the other thing about this is that if we had cut this the other way, you would have had to do exactly the same work except with all different figures, because you would have the 130 where the 110 is, you'd be finding the length of this diagonal, but your areas of the 2 shapes should still add up to the same amount, even though you're going to have 2 totally different areas at that point. So that's a nice way to see if you understand this problem, is to redo the problem, drawing the diagonal in the other direction. See y'all later.